Hello everyone, my name is Timothy Lee Grant and welcome back to another Leetcode, Neetcode journey. So we are going through this Neetcode map and hopefully going to be able to improve our Leetcoding abilities. So let's continue and go to group anagrams. That ought to be fun. Okay, cool. So let's start. So given an array of strings, okay, group all anagrams together into sublists, okay? You may return the output in any order. Okay, so I want to create sublists, and each list is what? Group all anagrams together. Oh, okay, so each sublist in my big list, right? So I'm going to have a list of lists, okay? So each element inside of my list is going to be anagrams of each other. So I'm going to have a list of lists of strings, kind of like that. Okay, an anagram is a string that contains exactly the same characters as another string, but the order of the characters can be different. Okay, so like A and C and T is an anagram with CAT right there. Okay. And then we have a list, a big list, which contains items of lists, which contains strings. So one of these is here, act and cat. Okay, so that kind of makes sense to me. Now, how are we going to do that? So we're given a string or a list of strings, okay? And now I want to group them together based on if they are an anagram or not. All right. Well, I remember we did an anagram problem a few videos back, and I was going through like, okay, A and C and T, and I would add that to my dictionary and see if another word had the exact same A and C and T, the same length, all of that. But in this case, I would have to it's very fuzzy. How did I solve it last time? It was like I had a dictionary, and in that dictionary I had a letter, and then the frequency of that letter. Okay. Okay. And then I went through that, right? And based on if the word I was looking at, if the second word, I'm trying to even remember what the problem was. I remember it was something with anagrams, and I remember I used hash maps, and I'm trying to figure out, did they just give me two words, and I was trying to figure out if these two words are anagrams? I think it was that. Okay, then that problem's actually significantly easier. Yeah, so that one is, yeah, that makes sense. Okay, so I have a hash map, and I say, hey, I add each letter. Let's just say that I have two words. Like, I'm trying to determine if act and pots is an anagram. Okay, so I take the first one and I put each letter in a dictionary. So I put the A, and then I put the frequency as 1. Then I put the C, and I put the frequency as 1. Then I put a T, and I put the frequency as 1. Then what I can do is, and you guys pointed this out in the comments. Oh, actually, to determine if the number of if the numbers, sounds really stupid when I say it out loud because it's just so obvious, but I didn't think of it. Just check the length of the two and immediately return false, that they're not an anagram based on if their lengths are different. Okay. Obviously, the way I did it was very convoluted. I ended up taking things out of a dictionary and removing things from the dictionary and then checking if both dictionaries were empty, but we're not going to talk about that because it's much more elegant just to check, oh, are the lengths equal to each other? So, so I had a dictionary, A with 1, C with 1, T with 1, and then I go here and I create another dictionary. I say P with 1, O with 1, T with 1, S with 1, right? And then I check, like, hey, for each of the values in here, like I loop back over my dictionary of the first one and I say A, and I have frequency of 1, is that the same for this dictionary? Nope, and then I return false. But in this case, I'm not asked to find if there's an anagram with just 2. I'm asked to group all of the anagrams together, which is amazing. That's awesome. So group all anagrams together into sublists. Man. Stop, pots, tops. I mean, I could do that method for every single word. Like, that would be a horrible solution. What I'm thinking about is checking, like, okay, so the first question that I did in previous videos was checking, is this an anagram with this? So it's just comparing two. So I could technically compare, like, is this an anagram and is this an anagram? If it is, I put it in my little special, I put them in a sublist together, and then I check, is this an anagram with this, and is this an anagram with this, and is this an anagram with this, and is this an anagram with this? Okay, then I check, is this an anagram with this, is this an anagram with that, is that with that? So just going over that is O of n squared, but each time I check, I need to go through that entire thing of adding each letter to the dictionary of both of, actually I'd only have to do it to one. So that would be significantly worse time complexity. It would be O of n squared, but then each time I do that, I have to put in the number of strings. So O of n squared times m, where m is, I don't know, the average length of the strings. So obviously that's not the solution that they're looking for. the exact same characters as another string, but the order of the characters can be different. Yeah, well, I mean, is there any other data structure besides a dictionary that might be useful? So we have sets that are what? They're unordered, unique collections. Can I use a set here? Well, I don't think so, right? Unordered. Well, I mean, I could use a set to check each two. But that's still O(n) squared, right? And I would still need to add each character to that list, or to that set. So that doesn't help me. Okay. So do we possibly want to just try to code up the bad solution and then say we can't figure it out and then go look at the good solution? I think that's what we have to do, because I have no idea. So let's just even see if I can code up the brute force method, which, let's see. I don't know if I can. So what do I want to do? For word in strings, STRS, okay? Now I want to, for second word in strings, but we want to I want to get this word, and then I want to get this word, okay. So I need something to do with like the starting, stopping. Okay, so for word in, then I will have to do enumerate, right? Strings, and we have index 1 and word. Then I'm gonna have index 2 and word in, same thing, enumerate strings. So now, while second word, okay, so we're gonna keep going until second word is finished. Yo, I have no idea what I'm doing. want to see something. Does what if I just say fuck it to software engineering and just keep going as an embedded system? Like, no, if you want. Yeah, let's see. For top tier companies and others working on Leetcode can be more common. Okay, great. Like, maybe I just continue as an electrical engineer. I don't know, man. Maybe I just continue as an electrical engineer and just be like, eh. I hate this so much. Well, second word. Some set equals like that, while I don't know. Some set dot add second word. I don't know. But this is gonna add the entire word, right? Like, I don't want that. I just want. All right, so this is such a bad solution. So I failed on every single count. I failed, like, to understand. No, I understand the problem. So I didn't fail there, but I failed to even implement the brute force method. I failed to even think of a real method. So I failed on both counts. What I'm going to try to do here is, because I can't even figure out how to implement the brute force method, I'm going to see if Copilot even understands what I'm trying to do. Can you even understand what I am trying to do here? If so, can you implement it correctly, but keep the same idea? Okay. Okay. I see what you're trying to do. You're trying to group words that are anagrams of each other by iterating through the list and comparing each word to the other word. However, there are some few issues. Some set creates an empty tuple, but it looks like it's meant to be a set. So, okay, so I need to do that set thing. So while second word doesn't really serve a purpose in this context, you're trying to track ungrouped anagrams. The logic checking if keeping your idea intact but making it work. Okay. Instead of looping through pairs, we can use a dictionary default dict list to store words with the same sorted letter structure. A set is not necessary. Anagrams can be categorized efficiently using their sorted string as a key. Okay. So default dict of list for word in strings. Use sorted characters as key. Tuple sorted word. Okay, so we're sorting the word, and so each time because the word is sorted, it's going to be the A, C, C, D, K, J, 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 right? Like each word is going to be kind of the same, whatever I'm trying to say. Anagram groups, key, sorted, append, wonderful. Return a list of the values, that's great. So then we just, okay. Is that the optimal solution? Okay, so it is the optimal solution. Is that also what he did here? Result default dict. Okay, so for S in strings, sorted S equals, so we are taking this S, which is the word, we're sorting it. Okay, so it's going to be, if there is an anagram, the sorted two words are going to be the same. And then we are joining on an empty space, so each letter is joined as an empty space. So this is going to return a string of the sorted S, right? Sorted, yeah. So sorted S. Now result, which is a default dict, and I am, here's the key, which is the sorted, and I'm appending S, which is, okay, I think I see what's going on. So you're creating a default dict, and then of each sorted word, and the value is the normal word, right? Like whatever. So this one, ACT, so this is already in sorted order, but we're going to have ACT here as the key, and then value is we're going to append ACT to it. Then we're going to come here and see CAT. So now I sort it and I get ACT, and I put that in as the key, and then I append CAT. So now I have two values in my dictionary with the key of ACT. Okay. And then I do what? After that, not that one, this one. So now at the end, okay, so this list function, I'm not too familiar with that one. I guess this just takes, judging by the context, it takes the dictionary dot values. So I'm getting the values, which are each of those words, and I'm just creating a list out of it. Oh, it's normal list. It's not like some other, okay. And then I just return that. Okay. So hash table. So this one right here, I'm creating a default dictionary, or this guy, Mr. Leetcode, what's his name? I actually don't know. Anyways, Mr. Leetcode is creating a default dictionary of lists for S and strings, so he's iterating over the S's, count 0 multiplied by 26. Okay, so 26, I know that there's 26 letters in the alphabet. Okay, so he's creating a list of 26 elements. Each element is a 0. Okay. So for C in S. What is S? S is the word, right? Yeah. So for character in, okay, count minus of A. Is this because we're considering like ASCII, so we have to minus the ASCII A? I'm not quite sure what the ordinance function does in Python. Okay. Plus equals 1. I mean, it's cool, like, if you don't want to understand it. I mean, it's great, like, that's cool, I guess, but, yeah, I don't know. What is he doing here? I don't know, man. This implementation of grouping anagrams using character frequency approach To restore grouped anagrams, each key represents the character frequency of a word and yeah, well, I mean, there you go. Like, wow, cool, awesome. I'm not gonna read all that. Okay. Well, by the way, when I was at work, right? The company is actually doing pretty good. Like they're expanding, and they're hiring a lot of new people. And I was listening to how electrical engineers interview, and it's so much different than software. It's so much different. Like they'll be like, tell me about your experience. Have you worked with high frequency? Have you dealt with this? Can you tell me about a project you built? Can you tell me about how you would solve this? Like, not oh, solve this leak code, solve this leak code, solve this leak code, or something like this. No, just like, oh, if you have I don't know, some if you have a circuit that is consuming too much power, what are some of the methods that you might use to see if you can reduce? What would you be looking for? Stuff like that, right? It's I was listening to it. I'm like, oh my goodness. Okay, it's so much nicer. So much nicer. And maybe I would just continue with electrical. I don't know. Well, anyways, that's great. That's cool. This is wonderful. Just what I was hoping to see. Um, have a good rest of the day. My name is Timothy Lee Grant, and goodbye.